So very great afternoon, dear participants. First of all, I would like to thanks Dr. Apte Madam for adjusting the time period as per my ability, and thank you participants. So I would like to give warm welcome in my session on smart grid in 1 week FDP on modern trends in energy systems, organized by Department of Electrical Engineering of AISSMS College of Engineering in association with IEI, IET and IEI. So let us start. So first of all, I would like to reflect on my form. I had given one form. This is my habit of taking pre-session survey and designing my session depending upon the participants' interest. So 30 participants have filled up that pre-session survey, which Apte Madam has posted on group before 2-3 days, because I wanted to make my PPT in that way. So it was asked in that form that what is the objective of doing this FDP? What is the objective of you that you are doing FDP only for certificate or some another objectives are also there? And what will be your objectives for attending session on smart grid? And then what do I expect in sessions? Means what do you expect in these sessions? How I can frame this session? What are your objectives to attend the session on smart grid? And what is the objective after attending the session also? Not only while attending session, but after attending session, what you would like to do. So this is the survey, pre-session survey. So even if we are teachers, one fellow has given not interested in the topic but only attending for certificates. So this is one, but majority 12 and 15 are given. 12 are giving basic knowledge and 15 have given depth in knowledge. So I have framed this session as this is near about. I am giving all the domains knowledge, all domains knowledge as per IEEE, and one or two domains where I have implemented that all technologies in my research work. I will show that in depth along with what I did in my research. So that will help you for the participants who are interested in carrying out PhD. So for these 6 persons, I have set my session that they will get idea how to carry out research in the smart grid area, how to define problems and what you can just do exactly. Okay, so I hope that 6 people will be definitely motivated and they will also get guidance on how they can proceed further in their research activities, not only for PhD but for publication papers also in the area of energy or smart grid or whatever you are interested to publish papers. Okay, and I had asked that whether you had done research, so nobody has done the research, so I had not gone into the depth up to that level. So this is also I had asked that are you interested to teach the course? So 10 persons are interested to teach the course. So definitely I have framed the sessions because I have taught this subject at UG and PG level also. So I know how it will be helpful for the teachers who are interested to teach. And then I had also asked whether you are teaching the subject. So T3 are already teaching the subjects. So they can share along with me. They can put give inputs, and then all the parts related to this means I had asked different questions, and then after the sessions, what you would like to do in the area of energy systems, because our FDP theme is energy systems or smart grid. So as I am working in various committees at international levels, I would like to give a number of opportunities. So I am interested to carry our relationships further, not only for this session, that is always my participants go along with me for a long time. So I would like to give you guidance and motivate you and just increase your contributions in the IEEE activities, because I am just having in smart grid and smart city and education society also number of opportunities I can give. So please fill up the form after this session and just take it seriously. Then writing paper, if you are interested in writing paper, not only in areas, all areas related to technical educations or smart grid, number of international opportunities are coming in 2-3 months where I am working as a organizing committee members. So I would like to motivate you, give the guidance, just come up ahead. Okay, so then I need to work in these areas and also basics of the smart grid clear concepts. So this was the form. So along with this review survey, I have just frame outline of my session. So I would like to first explain the learning outcome, because unless and until we don't set outcome objectives, we don't see outcome. Nothing there is a use of learning and attending any session. So we are teachers. We know what is the importance of defining learning objectives or learning outcome. So we'll first see concept and definitions, as majority don't know. Then architecture and domains. All domains I am going to explain. Then smart grid technologies. Majority of smart grid technologies which I have implemented, that I am going to explain, so that you will learn how these theoretical concepts, what we read, what we attend, how we can implement for paper publications and our research work. So that technology I would like to tell you along with my case story of implementation, how I implemented. And then I would like to focus some light on present status of India and US also. What is the present status of smart grid? And then challenges also. And then I have gone through detailed survey. One or two participants have written they are interested to have informations about the smart grid institutes or labs also. That also I have just done survey myself, and I added a lot of stuff in this PPT. So along with, because if we approach these smart grid institutes or the research lab, definitely we get a lot of help. Already I have approached and I have contacts with them also. So personal growth opportunities in the area, and then we'll see question answers. So reflection two now. Before proceeding the sessions, I would like to tell you, just think 1 minute, at least 1 minute. What do you want to accomplish by after this session or this energy systems FDP? How are you going to accomplish it? What steps will you take to accomplish your objective? What activities will you do? How will you acquire the learning? Because see, learning is never happening by listening. The best way of learning is to teach. That is why I just take opportunity to take any sessions. I just prepared and then just I teach, because by teaching we learn 90%. But learning never happens by just hearing. So under what conditions will the learning occur? So see how you will learn in this area. So learning outcomes I have framed like this. These are just cognitive levels, knowledge domains. So after attending these sessions, learner will recognize the basic concepts and technologies of the smart grid, then interpret the difference between conventional and smart grid. So this knowledge you will get it. And then higher dimensions outcomes I have framed, you will able to select work or problem areas for research, might be for PhD or for paper publication. Definitely you will get idea how you can select a work area, or how you can define your PhD problem. Okay. And then how you will also able to generate ideas for research and paper publications, not only a domain or area problem, but ideas also how I can carry my research further. Unfortunately nobody is doing research in this area. I think just you can start, and then you can generate ideas, okay, for paper publications and research. Then because I have set the sessions like that, you will just get ideas how paper publication can be done. Then predict personal collaborative growth areas activity. Number of participants have given choice for this collaborative activities. Okay, so majority are interested in collaborative activities. So do spend 5-10 minutes after the session also. Then prepare a development plan. I hope that today or tomorrow after completing this FDP, you will develop plan, your development plan, you will prepare it. Okay. Then only I can say outcome of this session or FDP will be fruitful. So let us see what is smart grid. Can you see this picture and tell me which is this, whether it is smart grid, tradition or smart? Put your reflections in chat box. After madam, can you please tell me chat box reflections, because I will not switch your window. Yes, participants, which is this grade, tradition or smart, and why? If you will like to share, then I will take sessions interactively, or I can just go on proceeding further. So any reflection, what is this? Is it a smart grid or conventional grid? Or you can just give wise reflections or in chat box. Yes. Do you want to have interactions? Whether this is smart grid or asked which is this grid transition, smart grid or just traditional grid. So you can just see here renewable energy is there, okay? And here smart cities are there. Of course, it is a smart grid, okay? The smart grid and not the traditional grid. So what do you mean able are at relevant or result oriented, and then T means time bound. Smart device, we just say that the electronics gadgets who can share in the both way interactions are possible. Then what is smart grid? You will think and you will answer at the end. Okay, smart grid. That is just acronym. You will tell me what is stand for S, or just go on adding describing qualities or attributes of the smart grid. So main attributes of the smart grid, if you'll see here, traditional grid is having unidirectional flow of electricity. But in the smart grid, both bidirectional flow of electricity, informations, telecommunications will be there. Means energy flow will be bidirectional, data will flow bidirectional, decision, actions, communications will be bidirectional. So after the end, you can think it who is the smart participant and listener. We'll just see. I would like to have a reflection at least at the end. What is S stands for? M, A, R, T in the smart grid. So smart grid means majority, because smart grid is a very vast concept. It is the system of system. So everybody is defining in different way. Everybody's perception is different. We cannot describe or explain smart grid in particular way. Okay. So majority things in the smart grid are it is having advanced sensing and advanced measurement techniques. Then advanced components. If you'll see fault detectors are advanced, and then renewable energy advanced concept means it is not only at the generation side but distribution side also, means consumers are also providing the energy. Then it is also advanced control method, so everything you can control in a bi-directional way. So smart grid is having majority things, and of course important thing is improved interface. So all these are the main attributes of the smart grid. So how we can define smart grid? So smart grid is the integration of information and communication technology into electric transmission and distribution network. Okay, but if you see on the majority aspect of distribution, we call it as a microgrid. Okay, then emerging vision of the smart grid is broad set of applications. I mean, number of applications will be there, softwares will be there, number of hardware, additional advanced hardware will be there. Technologies will be very advanced, integrations, interface, and intelligently controlled. So smart grid main attributes I told you, two-way digital technology, and of course objective will be for efficient management, power quality, faultless or self-healing, self-resilient. All these characteristics has to be there. Number of literature I am referring, but it is misunderstood that smart grid is only of a advanced technology. No, objective is that high quality and then self-healing. This is very important. Okay, that will be never as a traditional system. So in every stage of electricity cycle, you will see replacement of the technology, replacement of the old infrastructure, and objectives will be also different. So we can define smart grid an automated, widely distributed energy delivery network characterized by two-way flow of electricity information, capable of monitoring and responding to changes, and in everything from power plants to consumer preferences to individual appliances. But how IEEE is defining smart grid? It is defining as a large system of systems. So smart grid domain is expanded into three smart grid fundamental layers. IEEE has defined three fundamental layers for the smart grid: power and energy layer, communication layer, IT and computer layer. Okay, so these are the three main layers. The layer 1 and 2 are infrastructural platform. These are infrastructural. But if you'll see, means 1 and 2 are enabling infrastructural platforms for power and energy that makes the grid smarter. So smart grid measures, communicates, analyzes, and acts in real time, right across the network. Okay, and also from the back from the network also. So Department of Energy, US Department of Energy is considering smart grid as advanced components, sensing measurement, integrated communications, advanced control, improved interface and design support. See, here no quality, no reliability, self-healing is mentioned, but that is most in the smart grid. So number of definitions are there. So you can just see it enables active participation by consumers. Consumer has a very important role in the smart grid, because you can understand that we as a consumer can supply energy to the grid with our renewable when it is excess. So we are having active participations in managing our demand and all the other things also. So it accommodates all generation and storage options. Now enables new products, and then digital economy optimization is there. Resilient and self-healing, I told you. It has own capability to come out from the faults and various outages. So we can understand smart grid majority two-way communications, real-time monitoring and control, visibility and transparency, cost reduction and efficient. Now let us see how smart grid will consist of and how architecture or domains are there. So five main domains of smart grids are considered. So grid domain means bulk generation, transmission, distribution. Then smart metering is this. I want to explain this in detail because I have patent published on this smart meters applications and programs also. And then customer domain. So smart appliances, electric vehicle, communication networks, and communication networks, interdomain communication systems, service provider domain, markets, operators, service providers. So it is a huge. So IEEE smart grid domains, you can see that it is just having additional feature. Generation, bulk generation and non-bulk generation is also considered. But here also I will tell you non-bulk generation will come in the distribution. Okay. So that will be also one thing you have to note it. So National Institute of Standards and Technology has considered these domains. So bulk generation, transmission, distribution, custom. And now you can just see the picture. So this is what it is, the picture with the domain here. So bulk generation, transmission, distribution, customer, and in customer renewable energy is shown, where IEEE is showing bulk generation and smaller generation also here. So bulk generation means here it is considered renewable also. But renewable is not a bulk generation. Okay, so this number of variety literature will indicate you different things. So conventional resources will be also there, and renewable resources will be there. Then transmission, what is the change in transmission? You can see this is the conventional. So this is indicating domain. But in transmission, you can say that advanced measurement, protection, stabilization, and optimization is included. And here you can also see storage is also required related to the substation. Now, just now, the cursor has finished on the batteries. So this aspect is additional in the smart grid. Then what is the domain, distribution domain? So in distribution domain, if you see, also storage is required, renewable energy is there, means generation is also included in the distribution. Okay, small generation. Okay, so that is the change. Then customer domain is huge in the smart grid, because customer is playing role, active role. So energy devices, smart devices, customer will manage their load, customer will change their load according to the pricing system. So number of additional things are included as compared to conventional distribution system. Then in market domain, this is the additional domain. Okay, why market is required? Because we have to manage load, we have to import export energy. So separate department is there. Domain means department is also there. Earlier MSCB we just used to call, which was the centralized system. But now it is the distributed system. Instead of MSEB, MSEDCL, distribution sector is different. Market service companies are different. So service providers and market is also very important role. Okay. So deregulations, demand side management, and demand regulations, so that will also depend on this. So operation domain is also very vast, because it is a system of system. This is complete new addition in the smart grid. Number of variety of advanced software applications, operations have been added, and because it has to be self-healing and self-regulate and self-resilient. So all things smart grid has to take it automatically. Okay. Then this is the service provided. So just now I explained the service will be provided. So understanding smart grid power flow and information, main concept is that power is flown in traditional system in one direction, but you can see here it is power flow is unidirectional, and information flow is there. Number of additional networks are there, wide area network, then neighborhood area network and home area networks. Number of communication advanced technologies are coming. So when we talk about the smart grid technologies, core technologies are like this: smart meter, smart sensing, smart protection. So I will explain this, okay, because that is more related to the electrical engineering. But when we say energy storage, that is coming to the microgrid concept. So I will not take any of this. And then if you see transmission and distribution functioning, then wide area monitoring systems, and then market settlement. So out of this I will just extend this wide area monitoring system. Distribution side I am not going to extend this, but meter data management we are considering smart meter. And both combined transmission and distribution automation is also technology is also there. And distributed resource management is also there. So if you are thinking to carry out PhD work or publication work, you can consider where I am strong, whether in sensing measurement I will work, or I will work in advanced and control methods. If you are specialized from control, you can focus on this. If you are specialized in power system, you can focus on this. Or improved interface and decision, electronics peoples can think on this. And advanced components. So let us see sensing and measurement technology. We can say it is a component or technology or functioning. Different words are considered in smart grid while explaining. So sensing and measurement technology means smart meter. So this is a component also, and it is a technology also. So smart sensing. Then wide area monitoring system. So I worked here. I work using smart meters, and then PMU. I just found fault diagnosis. Complete fault diagnosis I did. So that way we will explain this. We'll discuss this in detail. Okay. So advanced control methods means monitoring and collection data, analyzing data. So if you are very strong in data analytics, you can consider this real time and predictive operations, then providing informations and solutions to the operators, integrating different enterprise. Then we can see that improved interface and decision support. What are these technologies? So data reduction technology, data to information to action, visualization, then speed of comprehension, system operation training. So number of technologies are there. And in advanced components, we can consider facts, fault current limiters. I have just shown you. So I use these advanced fault current limiter techniques. Then superconducting transmission, just now Karandikar sir might have thrown the light on this microgrid, advanced switches, and this integrated communications will again have number of things and reputations also. So smart grid towards an intelligent future. This is very nice video. Now I will just skip it. I can post it in the WhatsApp group after my session. So let us start with smart metering. So what is the smart meter? Smart meter, we are hearing the word. So it is intelligent device. So it is intelligent device which can not only measure the energy but also give information, communications two-way digitally. Earlier we used to use energy meter and people used to come and read that reading. But now here it will be known to us digitally. Main important difference is we can just read real time reading. What is my exact energy consumption now, not monthly and all this, real time, and I can control it in future. I can take decision. No, no, it is beyond now my expectation. Now let us switch off from this energy supply to the another supply, and I will just switch my supplier, or then I can just get my energy in a reduced rate, or just I can just sitting here now in office, I can just give control to my home automation. No, I don't want now machine to operate, air conditioner to operate, switch off, because here rate is also different meter I am observing. So this is with possible only with the smart controlling, and just I can reduce consumption. So smart meter has given lot of benefits. So smart meter architecture will be mainly hardware and software. Then in hardware, you can just see voltage sensor, current sensors will be different, energy metering integration will be there, microcontroller will be there. So initially, I started with this smart grid technology, and then with Amy, I just did one project, my Amy student on the smart meter. And then after observing its success, then I thought, why not to use smart meter in my research? Okay, so role of smart meter I proposed at that time, it was very new concepts. Smart meter was very new concept, and I extended how this smart meter can be used. So what are the benefits? So remote monitoring, then manpower reduction. Just now I explained this, theft detections, outage management. So I use this in the outage management. Then energy management, integration of distributed and low operational costs. So all these I explain with the example how I can reduce my energy bill. So smart meter is important component of advanced measurement infrastructure. So AMI is the very important technology, or we can say functioning part or components in the smart grid. So what is AMI? Advanced metering infrastructure. Definitely it will have smart meter, and definitely it is a backbone of smart grid because it will provide the means for two-way communications. So two-way communication is possible with advanced metering infrastructure. Okay, so we can just do this integrated system of the smart grid meters, data management system, and communication network. Means three components are there. So we can say meter data management system, and then this advanced communication technology, and the smart meter. So AI is having main three components. Data has to manage, metadata has to manage process for the decision making, monitoring. So it is possible with the advanced communication technology and smart meter. Okay. So interconnection to promise-based networks, means home area networks are connected, and then ability to read other or on premises, nearby commodity meters also, gas, water, energy meters. Then it will be useful for power outage, tamper detection, and voltage. So that I told you. So this is the, you can just see a simple brief diagram. It is given by ISGF Institute, or you can just say Smart Grid Forum. So smart meter is there, and communication technology is there, and meter data management system will be there. So this is giving detailed picture. So this is all home our smart devices. We can just interlink. What I told you, the example. Sitting here in home, I can control my machine, my air conditioner, or my smart devices by considering the rate of energy. And now it's not possible. In future, it will happen. Rate also I can watch, I can switch on my supplier, I can manage my devices sitting here. So this will be possible through the Zigbee home area networks. And then it is given means, with the help of smart meter it is possible, and then it will be given to the neighborhood area network, and then wide area network, and then central system will be also there, and then management data systems will be there through GIS. Okay, so this will be provided done by the utility, and this we can observe it. So these are the details of the advanced metering structure. So in short, it is a combination of communication network advanced, of course, metadata acquisition system, control center means data control center will be there, meter data management system will be there, two-way communications will be there. So it will be having different networks. Okay, so now this we have talked about the core technologies. I will show you how I implemented these core technologies, and then now let us see. I suppose something wider related to the transmission. This I will not talk. This is coming aspects in the microgrid. So wide area, actually microgrid is the part of smart grid, but we can just differentiate. After madam has kept session on microgrid also. So what is wide area monitoring system? This is the very important concepts, and I use this concept of PME and this. So wide area monitoring systems, or WAM we can call wide area monitoring system. So wide area monitoring system will consist mainly phasor measurement unit, which are called as synchro phasor also. Then PDC means phasor data concentrator. And then global positioning system. Of course, GPS is required for synchronizing for the phasors. I will explain this. Communication channels, visualization, wide area situational awareness and wide area protection and control will be there. So what is GPS? So you can just see in a power system, all we have phasors, voltage, current, phasors, phase differences are there. So mainly two components are important, and if you'll see, it is a wide area monitoring system. So widely means for it can be complete for one country also, and thousands of kilometer distance will be there. And if I want to take readings from at different locations in the grid, then how I can take? Because you can just see distance is too much, time required is very important. At the same time, I must have reading everywhere. Then only I can monitor the system, I can assess, I can do calculations, I can decide, predict, control. Yes, so this is required at a very same instance, and this is possible with the GPS satellite clock. So this is a very high resolution clock. With this GPS satellite communication, I can send message to all PMU, and then PMU will take readings from the network at the same instant, and it will be synchronized. So it is called as synchronism. So this is very important role of GPS. Then next important component is PMU. When I was doing research advanced at that time, North American system had installed, and in India, it was just started thinking to develop some pilots with the PMU, and that was done by Miss IIT first. But I use this PME concept in my research. So as I told, GPS satellite will give you the time stamping for all the readings, and then PME will be taken readings, and then PME will measure voltage, current, magnitude, phase angles at the same instant, and it will give the time stamp also. Because see, when we are taking reading from the system, we must associate that data with the time, because frequently changes are happening in the system. More fault has occurred, what is the situation, what is disturbed, where it is disturbed, I want to locate that. So I must check at what time it happened, after fault what happened, before fault what it was there. So all data it is required to associate with the time stampings, it will be used here, and then all PME will do and calculate that voltage, current, phases, and they will associate the stamp from the GPS to all the data, and then all this data will be given to PDC, phaser data centers. Okay, so you can just see that it will be assessed, and it will be find out what is the data wrong, whether time lag is there, some false data has come done there. So local PDC will take the decisions, and then it will be just associated with the higher supreme PDC. Okay, so this is important part in the smart grid. So you can just see this is given in the description what I explained. So sampling rate of PME is very important, 40 samples per cycles. But nowadays in modern, it has gone to 120 also. And not only PMU are considered, but micro PMU, which are very fast, they're also coming up, especially in distribution system. Micro PMU are used in distribution, and PMU in transmission. But PMU we are just calling for distribution also, but that is the latest concept. So it has gone to very high rate also. So imagine 40 samples per second, how fast PMU is working. But PDC, if you see phasor data concentrated, that PDC will work at a smaller speed. Okay, because data will be taken by PMU, 40 samples per seconds. So how many samples per second? 2400. So I use the same frequency range for taking the sampling from the system, and I assess what is going wrong in that fault. Okay, when fault occurs is line to ground, double line to ground, I just take all the samples, compared, I find out some features, and then sampling rate also I use the same. So PM uses digital signal processing, DFT, particularly DFT. I use DFT also for signal processing. And then you can just see PDC will just collect that, and it will just work at the rate least 30 to 60 samples. But nowadays this is also different in latest. So two quantities will be compared, voltage and current, phasors and magnitudes. Okay, so basically phasor measurement unit will be having these GPS signals and filters, and then this is you can just see signal processing techniques, microprocessor. So I have not done hardware, but I use this PMU PMU concept and sampling and that signal processing. So applications of PMU will be in real-time monitoring, fault detection and location that I will show you, then protection, security and many. So PMU versus SCADA. Okay, we are familiar with SCADA, but PMU is replacing SCADA. When I started my research, I visited different SCADA systems in India and abroad also, and I found that what is the main problems with SCADA and why SCADA is not being so much popular in India. I just found very bad situation due to lack of technology. People are not using because they don't know how to use, and they used to diagnose fault and locate fault with traditional way only. Then I just sent one paper on survey of this. That was my beginning of paper publication, starting with the SCADA status. Then PMU, you can just see 10 to 60 samples per second, and say this SCADA rate is very less. So if you want to monitor system, we have to have very advanced and fast devices. So dynamic transient stability is possible with such advanced technology, while SCADA steady state observability. It gives only magnitude, here magnitude and phase angle. So time synchronization is not possible in SCADA, but PMU has made it possible. Okay, so number of this is useful for local monitoring. Generally SCADA for distribution, but PMU for distribution also and for transmission systems also. So you can see the difference between PMU and the SCADA measurement and this resolution difference. Okay. So these are the IEEE standards, communication standards used for SCADA and this, that is. So what is phasor data concentrator? So as I told you, phasor data concentrator will be working with low latency, means speed of operations will be in milliseconds, while PMU will operate at microseconds. And then this is it will receive data and just synchronize stamp data. It will give to the higher level PDCs, okay, for different assessments. So here it is shown PDC and storage, because data has to store. Where it will be stored? Of course, in PDC it will be stored, but PDC do synthesis for removing wrong data, and if time some lag is there in all the data, that also it will check, and it will be stored for number of applications here locally. And then superior PDC will also be in functioning. Okay, so here phasor data concentrated work like this. PDC and PMU. First, it will be giving signal. PDC will give signal to PMU, and then PMU will give PDC to the frame response. And then PDC will tell you, okay, start data, now take data. And then whatever data frame PMU will take, it will be given to the PDC. And then PDC give command to the stop. Unless and until it don't give stop command, PMU will go on giving and taking the samples. Okay. So this is the detailed diagram. So here I am showing you Bangalore SRLDC diagram installing PMU. I had visited Bangalore CPRI lab because we should not do only theoretical research. We should see what is happening practically in the system. So I started visiting, as I told, SCADA and all this PME installment, Bangalore CPRI lab. And due to that, I just got too much exploration, actual practical explorations, contacts also. So this is the system actually. How many PMUs were installed at that time? 335. So phase 1 to 25 and phase 210. So this is was just one diagram, actual implementation. So wide area monitoring system will be using this, as I told initially and started. PMU is important, PDC is important, and then wide area monitoring system means monitoring will be done with the PDC and superior PDC. So that is the main protection system in the smart grid. So 5 levels are there. So in 5 levels, we explain this PMU, which is level 1 and level 2, and PDC at level 3. And I told you Supreme PDC will be there also, but it is not shown in here. But here level 4 means data visualization has to be done. Analysis has to be done, assessment has to be done, recording, most data has to be recorded. It will be recorded, stored here also, but different PDC will be there, regional PDC will be there, and all regional PDC data has to stored at centralized place also. So that is not shown here. And then protection and control functioning will be there. Okay. So this is a detailed diagram with the IEEE standard. So we need not go in that details. So you can just see this is the first level. Here it is shown four level. So like that, four level, three level, five levels work are there. So advantages of wide area monitoring measurements will be rapid protection, increasing the capacity and better usage of install equipment. You can even with wide area monitoring system, you can run your transmission line up to peak values also, because you are watching it, controlling, protecting. You can prevent blackout, because actually WAM and PMU started with this blackout experience only, I think around 2003 or somewhere. And that means huge blackout was there, not only in India but in USA, all countries. And then USA decided to work on that, and that was the invention started with PMU and the WAMs first in North American system. So these will be a benefit of optimization, improved planning networks, reducing disturbances. Now, ahead of concept is that wide area monitoring system PAC. So PAC will also consider protection and control system. So whatever we have talked, once we have understood this, we can understand various applications, software, and you can work for your research work publication here also. Software you can develop, and then which will be for protection related. I worked here for fall diagnosis, but protection also can be thought, or whatever we just learn in conventional system, load flow, fault analysis, stability, you can do all that topic in your smart grid. You will consider smart grid and you will carry out that same task, whatever you learn. That is what the research in smart grid. So what I learned, fault analysis, fault diagnosis, location, I just applied to smart grid. I took a smart grid and then I found out some applications, software application. Actually, I devised one formula where it may gave me lot of success while compared to other publications, to locate fault exactly and also find out the classification of the fault. Okay, so this is with PAC. So in smart grid technologies, I want to just focus latest advanced concept of IoT projects. So IoT is now booming up. Means microprocessor or some advanced. We can just see number of technologies are coming, and different countries are also started bringing IoT projects in the smart grid. Okay, so that smart IoT applications is smart grid means you can just see these are in future predicted applications. So here with the internet of things, you can use internet for different variety of tasks. So potential applications will be there. You can just see. India is just only started now implementation. I don't know whether implementation part is there. And now this IoT layer also has three layer or four layer. So this is one smart grid lab at Patna installed in LabVIEW that Patna. So you can just see. I will post the link. Now let us see smart grid management system technology. So how we can do that. So I will focus on outage management system where I work. So outage management system is locate the fault and just take a corrective actions and just do that corrective actions and get the result. Okay. So in that number of advanced devices are used, but IED was old, but I did not use IED concept. So intelligent electronic devices, multifunctional IED. And then fault passage, I use this concept. At that time, we just India has started, and I think it was installed first in Delhi, fault passage indicator. So I started thinking, why not to use this fault passage indicator? That way, my triggering started what is happening in the actual practical system. Then fault passage indicators, it will give you complete idea of the fault where it has happened, not dependent on the crew like previous experience. Time required was very huge, but this fault passage indicator will indicate, give alarms, give flash lights also. Different advanced passage indicators also started coming with intelligent line monitors and fault indicators. So these are the simple these fault passage indicators. Okay. So here, if you can see here, the average time to restore power supply is 40 minutes. Suppose any fault occurs, then how the system will restore into its healthy operations. So currently our traditional system at least 40 minutes, you know also how much time is required to restore supply. Fault is taken. Okay. So that we have to just understand. But how it has to happen very fast in the smart grid. So if you'll consider the smart grid, it will happen very fast. What is the time required? At least means 1 and 2 minutes is also very large, but you can just see our power systems are very huge, and due to the very huge power system, time required will be also sufficient. So let us see a case story of my implementation. So I just consider this problem of fault diagnosis means to locate fault, then identify fault type also, fault classify also, and fault location also. So complete fault diagnosis, I just define my objectives, and just also one additional objective, study present distribution system and finding measures of its improvement. Because if we cannot understand what is happening currently, what is the use of theoretical research. Okay, so this was theme generator, that smart grid to use smart grid meter concept, use advanced communication concept, then detect fault, locate fault, and just have the tripping and remote control. Okay, so this was the just the algorithm which I developed. So a pre-processing stage means fault currents or normal currents I just took, and Clark's transform I used. This was the pre-processing before the fault signal, and then feature extraction. I extracted a feature using wavelet techniques. Now number of things we just misunderstood the research. We just say I want to use machine learning, I want to use this wavelet, but these are tools. We have to focus what task. First decide the task, first decide the operation, and then decide which tool. Tool is not important. Even if you will use advanced tool, nobody is calling it as a research. Research will be there when your results will be compared with another research, and you are showing that your results are superior than the published results. That is called research. So focus on the task. So and then use any technique. I use wavelet because I was motivated by my um, Miss staff who conducted our sessions in the course before doing PhD. So that way I decided I will use wavelet because I was just impressed with contributions and all. So that first I took that signals, and I took various extractions, various features. I started with first the paper which was used with the entropy, and then I started thinking doing some different features. Okay, and then fault diagnosis stage was there, as I told you, details of layout and types of faults. So this is the flow chart of implementation. Now here, see, what first step is to start the research. Take any one paper and start verifying that paper. Okay, and while selecting the paper for verification, it is very important wise choice is there, because if you will take paper where no options are there, then what is the use? Because you have to do different things than paper. So I took using entropy paper, because in that paper it was mentioned like this, we can take these features. So I just thought, okay, I could not find out that papers using other features, and I got the research gap also explained in the paper. Okay, this researcher is saying another features can be used where I'm not getting that papers. So I selected that paper, and that was a very wise choice. Then I just took this and implemented as it is. Okay, so I took detail coefficient, approximate coefficients from the samples. These are the variations. I studied what happens when fault takes that at 5. See here, the features are very different. Then when fault takes this at A to ground, B to ground, C to ground, what is happening with this entropies? I found out the sum of entropies and entropies, and I just observed, okay, we are able to detect the fault. Okay, fault is at here, fault is here, you can just see values are higher. Okay, so I just did this, and the same paper app entrophies I posted it for the Springer conference, but I had done little different, and my result were superior to that. Application was done for the smart grid, and I got first award, miss in Springer conference best paper award there. So it was a good beginning with the validation of the paper, and that paper was included in the book on the smart advances in smart grid and renewable energy. So here you can just see that was in Sikkim conference, and I just explore Sikkim also. I never do any work for only one objective. Number of objectives are there. So here next I just spent on energy. Okay, energy paper publication was also there. I just wanted to compare, but energy results were not sufficient, like entropy. Okay, but I did that. I did entropy. So what is the energy? And I carried out it for comparison, because when your paper will be published, when your research will be there, when you compare with one method with the another, so energy I extracted and I compared. Are you listening? Am I audible? Because my network is weak. Okay, so paper publication, I just then done with energy. Apte madam, are you listening me? Apte madam, I don't know what is happening. Sound is coming, network and this. Apte madam, Apte madam, participant, can you listen me? Okay,
Yes,
so
madam. Yes, madam. Yes. We
yes,
can
because
listen.
here alarm is coming weak signal. Okay, then that energy paper I just did for comparison, and that's why my paper could get published in China conference. These are very huge conference I selected for exploration, because my objectives were different to have professional contributions. More than 1000, 2000. You can see Asia Pacific power and energy. Yeah, that paper was accepted in some another conference, but I took my that paper from that conference because I could not satisfy with the number of participants and the scope. And what benefit I could get immediately, that conference started putting me as a panel, means technical program committee members and this. So number of advantage I got why I selected good conference, because immediately my opportunity started in the good conference to do the work as a technical person and do as a session chairman also. So this one hint I would like to give you. Energy result was not good, but still I did for comparison purpose. Okay. Then FFT I took picture and I just carried out the research, and then this FFT and energy and entropy I compared and sent the paper for UK. Very grand conference. And there I also got the chance for session chairman, because conferences are good, work is good, number of comparisons are there. So this is what I want to tell you. Select good conference, and of course with the diversity of participants, diversity of organizers. If we take diversified means, areas, then we really grow. And my experience working in international is really fantastic. In local, number of politics are there, but in international, really you will get excellent opportunities based on your talent and capability. Actually, everybody is having same talent, same capability, only we don't mix up with diversified groups. So that is what I wanted to tell you here. So then I just extracted standard deviation feature, and this was very fantastic result with standard deviations as compared to previous. And then I did sensitivity analysis also, means changing the system conditions, fault resistance, and different variety, whether my method is study or no. I develop one formula, or just you can just say function. I call it as a function, and I showed it. It is study even if you have the changes of the fault resistance and it. So that is what one clue is there for PhD research. Always start thinking 3 4 chapters. I use research methodology because we have to have 3 to 4 contributions in our Nanded. We must have 4 contributions, 3 to 4. So I just first design my thesis. I design my what can be 4 methods, and then I started working. So always we have to think it. Exact research methodology I applied. Therefore, research took very fast way. then presentation was there, means you can just see comparison clue you can keep. You need to compare it. Okay, so what is the motivation or smart grid status in India? So if you see in India, two bodies are started working. India Smart Grid Task Force, ISGTF, and then India Smart Grid Forum. An initial pilot project of 14 projects were in the pipeline by Ministry of Power. Whole the funding was given by this Ministry of Funding. 50% funding, not whole, 50% funding was Ministry of Power, and 14 pilot projects were started. And all these you can see Ministry of Power, and then I told you India Smart Grid Task Force was made, and then India Smart Grid Forum, they just did all this. So it indicates direct interaction among entities this, and it will dotted line indicates that among just indirect. So here this I was in very good contact with ISGF, and when these pilot projects were started, I just reviewed their report, what is going on and what is this. I started communicating lot of helps we are getting if we contact the actual research labs and research you can say universities. They give, of course, in that is you can just see lot of exposures we get it. So here in 14 pilot projects, here demand side management, demand response, peak demand, it was proposed by the utility crew management, renewable energy, and we can just see today here we are successful due to these pilot projects. All these are happening, but you can just see here AMI was also important. Outage management system was also there. Distributed generation also was there. Okay, so these are some pilot projects, and this is the case study and findings, what could happen, what could not be implemented, what is not in use, and this. Okay, so you can go in detail. I am giving you all the references, whatever I use it after my session, you can use it and go into the details. Okay. So this is was some pilot project of Mysore. You can just see consumer outage, consumer awareness, and how they could find out losses and all this and minimize that. Okay, so this is what I just want to tell you. Go through that 14 pilot projects. So in Pondicherry pilot project, if you can see that pilot covers 87,000 consumers and residential segments. All these data are important to understand. 1650 smart meters were installed. Okay, and then you start defining your research, because you might be knowing it is new. You will be just referring the papers, but in practical situation already it might have started utilizing. It was my objective that I will take very latest areas so that I will get lot of opportunities ahead also, and it was very new. So way forward, if you'll see here, number of projects are in pipeline also. And then right now India is not complete a smart grid, because it was expected by 2020 it will be there, but now it is considered by 2030 will be complete a smart grid in India. Okay, so assessment and then this will be considered. Then 30 cities national smart grid mission consider that to undertake 30 cities, and I think in Maharashtra Amravati is taken. So here they are in Chandigarh, Amravati, and then Nagpur and Kanpur. Okay. So you can just see here Smart Grid Research Laboratory, CPRI. So this is very good laboratory to see the smart grid. I had visited there, and you also do visit that CPRI. High voltage laboratory is also there, and different concepts will be clear because they have actually implemented everything. Okay, then another lab smart grid pilot project of Indira Nagar is there in Bangalore. So these is the details of the research in the smart grid. Then wide area measurement system, pan India basis. I told you it is implemented. India started implementing that PMU, but only financial barrier is there, cost barrier is there. So smart metering is also there. You can just see we at year to 29, it was 3.45 crore installment was there. Okay, now what are the future plans? If you see, Vaikar sir and some other speakers have focused on this. What is the capacity requirement? 2020 we are here, and 2027 we will be there. Main objective was this for India. Different objectives were different for the different countries. For India, there was tremendous gap between load and demand. And that was the main intention, to reduce the transmission losses and make the system efficient. That's why India started looking for smart grid by looking to the other countries. So this is 5 year plan. So future plan you can just see 22, 27 now onwards in 14 plan. What is the plan? Stable and quality 24/7 power supply to all categories. It is just thought over that future status, EV charging stations, and there will be no end for this. In coming 10 years, all vehicles will be battery operated vehicles. Delhi has started in last week only telling consumers that come here and convert your vehicles into EV. Existing vehicles, Delhi RTO has started converting into EV. So there is a vast scope for this. Then you can consider here renewable integration of 130 gigawatt will be there. Dynamic smart energy efficiency program will be there nationwide. Okay. So present USA biggest foreign, I just took it top 10 utility smart grid deployments. I told you because whenever I am studying, I am observing North America, and that smart grid fellow I have also integrated, who is a Indian only. So biggest smart grid deployment is done in North America. They started with PMU only to resolve outage, and this Arizona Public Service, then Austin Energy and Con Edison and Duke Energy. Okay, so all these are top 10 things deployment who deployed a smart grid in the countries. Okay, challenges do exist. However, challenges do exist. So key challenges are government support has to be there. Then national roadmap is to be done with the implementation, and missing should not be there, because national roadmap, if you'll see, that was for India to make smart grid in 2020. Number of challenges we faced, so that is not happen. Then deployment of smart grid standard. This is the big challenge for the standards. Then ability of users to absorb. I told you that the users are not ready to use the biggest technology. I told you the SCADA also, not users, but operational implementers also. Lack of awareness is there, motivation is there. Increasing customer awareness programs and participation has to be there. Allocating costs properly and fairly among all stakeholders is also challenge. Lot of politics is happening in this also. So number of key challenges are there. Even if lot of benefits are there, AMI, and if you see AMI installation plan and what is the current situation, tremendous gap is there in that also. Okay, what happens with the smart grid in MACB? You just ask the people. They are just, I mean, many substations they are lying down as it is without installation. So number of challenges are there. Communication challenge is the biggest. Then flexibility is there. Compatible equipments is also there. So these are the challenges. Challenges for data analytics is also there, and this is the latest technology in smart grid. And latest smart research area for smart grid for computer electronics. Number of people can think for that research in data analytics. So that is also the big challenge is there. So, depending upon the potential and what issues can arise in the distribution market, this is the survey. So, Smart Grid Knowledge Lab I have included with the request with one participant. So, Knowledge Lab and institute and companies. So, if you see here from India, you can just see four, five labs are there. Then this is Smart Solar Energy Systems, India Smart Grid Forum. And I will recommend this first. You should contact and approach Smart Grid Forum. They have lot of things, not a repository of learning resources, videos, activities, funding, lot of things are there. And smart automation is lab is also there. I am going to give you all these links, so you can go through the portal of this smart grid knowledge portal. It's very good. Whatever you want to do in this area, start with this portal. Okay, I started with ISGF. I just started communicating with the main persons, and I got lot of knowledge. And I just started thinking that. So you be and go through this portal. At that time, portal was also not there. Okay, so portal is now very vast. You just explore this portal. So these are having news bulletins, and also see December 21, lot of competitions they took. They have students chapters also. Unfortunately, I could not do for my college this, because yeah, I miss this smart grid is for a B and PG. I tried to do that. It depends upon the interest of students. So you can form the smart chapter of this ISGF also. And then you can just see your main qualifications, job opportunities are also there. You can go and find out that job opportunities also there. Research opportunities are there. Then another important source is National Power Training Institute. This is also very important. I just explored that. I visited that and I tried to do the courses also. But I could not do that. But I was in touch with this National Power Training Institute also. Then a Smart Grid Knowledge Center. This is also very good. So you can just see this Smart Grid Knowledge Center. You can explore different things. You can go through that. And then smart manufacturing services and companies. Somebody has written companies. So the top in worldwide companies are ABB, power installations and energy sectors. Accenture is a service provider, top 10 worlds. Then Cisco, CDAC, and then this SAN. So these are the details what they exactly do. So what ABB is doing, leading power and automation technology company in the world. So these are the details you can just see. I don't know for what purpose you were requiring, but I just did the survey and added in my PPT. So Accenture is also world's top 10 IT consulting firm. Okay. Then CDAC. So all these are there, and you can find out what work they, and use of this will be for hunting your job and exploring the websites, and equipping yourself compatible if you are a student. Okay, so government ministries and utilities supporting the smart grid research. So as I told that number of means you can just see utilities and ministries also support. Not only support, they give funding also. So Ministry of Power is there, then MNRE is there. I had received funding in my earlier institute for our energy activities. Then Science and Energy Research, sir, also you can get funding here. I had received funding for my UK travel. Okay, so these will be supporting your research, smart grid research activities. So these are different. I think it is okay. I am going reverse. So research institutions, Central Power Research Lab, I told you CPRI example because IIT expert had told me visit that. I visited whatever persons used to tell me. I used to do that. Okay. So Terry is also good. I had have collaborations of Terry also for one important project, but that proposal could not sanction. But Terry is also giving you lot of cooperation and support if you want to do something in this area. Just go and approach them. Then CDAC, I don't know CDAC, I had not approached. Then opportunities for personal growth. I had asked you to reflect upon what you would like to do this. So number of opportunities are there. IEEE Smart Grid domains. Number of activities means educational institute, because basically I am working in the educational quality programs, monitoring and controlling the quality program. What IEEE standard Smart Grid do, Smart City do, like just suppose a webinar, going and approaching various expert, motivating them to deliver. Just now from my sister cousin IoT, I could arrange IEEE webinar. Now it is under review. So that way reviewing webinar applications, then reviewing and then maintaining the website. These domains we change frequently through the monthly meeting, and we put some calls for webinars and workshops and tutorials. Workshop was also my suggestion. They just take tutorials, but I said why not to start workshop also. So you will get number of opportunities if you start thinking and approach me. Then this smart city where also continuous flow of speakers. Dashboard means maintaining domain and videos also. Suppose IEEE contests are there. Ambassador project is going on where thousands of students are doing work for the ambassador, and at least 50 are there from India. And I am finding poor situation from our Maharashtra, that as compared to other states of India, Maharashtra is very much lagging all this, and that's why I decided to motivate people. That is what my intention is there. So in ambassador students project, students need to do lot of activities, organize programs, approach experts, and then that will be selected for the contest. So as a committee member for selections, video contents, whether to put it on the repository website or no, all these works our committee is doing. So I do have opportunities to give you these all the opportunities for student stuff. Only important thing is your interest is required and you should contact me. Okay. So these are opportunities I told you. Not only IEEE Smart Grid Smart City, but related to energy and sustainability, because number of conferences are coming. IUC is related to teaching and learning. If you want to publish paper of your own learning experience, teaching experience, how I teach this subject, what a different way I use it, what different way I use learn it. So number of conferences are coming where I am using as a committee member in this IUC. So that also I want to motivate number of teachers and start publishing papers based on their teaching experience, which is more simple, I think, than the technical. Okay. So this also you can contact me after the session. Number of opportunities are coming every month. And one thing is there, national circles you must interact. Here also I work at nationally, and when we just mix up with other state teachers, we grow very fast. If we are sitting locally, we don't know where am I. Okay. And my growth will never happen. But when we mix up with diversified people, here I'm just getting how other teachers are doing, particularly state, south state peoples. So here also lot of opportunities to work at national circles, clusters are there. Different disciplinary wise clusters are there, objective wise clusters are there, like project based learning cluster is there, teaching and learning cluster is there, outcome based education cluster is there, where we collaborate monthly. There we share the experience there also. If you are interested, you can contact me. One additional opportunity is women empowerment. 1000 webinars are in the pipeline, and that will be only for women. So if you can deliver this webinar, only can be technical, non technical, but that will be only for teachers. Please do contact me. So start, because I am very much interested, because teachers should speak for not the students but diversified participants, and then learning happens. We understand that teachers should learn, but how we have to learn it? By teaching. But how we can do teaching? We have to teach for diversified participants, like different stage, different area, different experts, different age groups. So here in women empowerment, think was to share your technical knowledge. Non-technical knowledge starts with the webinar, and that will be really fantastic learning. Okay, and then VTHO, my organization, NGO, I just focus on delivering sessions on holistic development of students, like human values or just behavior, stress management, meditations, spiritual techniques, or just like you can say leadership development also, because I have done a fellowship in leadership. So that is also, if you are interested, you do contact me. And then here I am telling you case story you can present for your related works. So these are one important webinar is happening today. Do attend this, that is free, and this is very good organization. If you just enroll today for fourth webinar, you will get lot of opportunities coming, and these are very high standard webinars. You will see that all higher authorities of the India is participating there. So quality webinars you should attend. And once you will enroll here, you will get lot of topics also related to teaching, education, advanced technology, renewable energy, green, and so what. So I have posted this link in my one PDF. I will give to Apte madam. She will post on the group. Okay. And this artificial applications, telling number of webinars are there. So my opportunity journey, as I told, this Anurag Srivastav I met in CPRI, who was director of Smart Grid Demonstration and Research Investigation Lab, Washington State. I just influenced by him. He was talking about PMU, and I decided, oh, I will use that. This is how motivation has to inspire from attending sessions. Knowledge and technical knowledge will forget after session, but motivation will be long lasting. Okay, and then I presented in UK. That is also I got then this market of Taiwan, Bangkok. I visited. I explored not only paper publication but I explored also. This was I just rejected paper. I took it and they started putting my just committee member all these opportunities. This is what electric vehicle charging I visited in San Francisco in USA. So there they just give free, this was the free station and very nice site was there. So it was operated with the wind, and we are in India, we are thinking solar based that electric vehicle stations, but that was operated with the wind. And then in energy is to travel. This also I wanted to tell for students, those who are interested, or staff also, to carry out research in Hawaii. Energy, lot of research activities are going. They are giving lot of funding also. So I visited department there. I just gave a expert lecture, shared the students. The different conferences are going, world conference. These are researchers I interacted. Students, research students I interacted. Then I just observe what way they are doing research, what exact, and they are very interested to show you. Mind you, one expert lecture that Henry was taken, I gave, but we are just now in touch. He analyzed from the students, gave assignment on my expert lecture. He told me how students did. He showed me assignments and how we arrange expert lectures. So that is lot to learn. I just ask them what exactly, and the people will spare time to you, which will not happen in India. Okay, so this is what I observed. We should not have hesitation to approach different peoples. They are international experiences, very really fantastic. You start thinking work at a wider zone, and you will really start getting what you want. Okay, so just references. These references I have put up. Exactly, I just finished in time. Now I would see how many participants are there. These references I am giving you. Okay. And feedback, 1 minute paper you please fill up, because it's my practice. 1 minute paper means only two questions where I need to improve what was a muddy point and what was a good point. This is also I learned from attending FDP only. So you give two questions, and that number of opportunities I have mentioned, you fill up that. So I will be contacting you looking at your interest. Okay. So please fill up this 1 minute paper form, or I will be posted after madam I will give you. So think on this. What is smart? Elaborate. If you attended session, you will be elaborating what is the smart. Think it. Okay. So I would like to say thank you. Let me see how many participants